Hello everyone, we are going to see formation of image by spherical mirror. This image we will make by ray diagram. Since we are knowing that there are two type of spherical mirror, one is a concave mirror and another is a convex mirror. So first of all we are going to see the formation of images of an object by using concave mirror. We will apply the rule of ray diagram while making it. So the image made by the concave mirror under certain cases, in that the first case is when the object is at infinity. So to make this, let us see a concave mirror, and it is principal axis. Select 2 point, one for focal point, another for center of curvature C, and this point is a pole. If object is at infinity, large object, large in size, so from the object parallel beam of light, a light we will take from object passing to the optical center, we are knowing reflected back in same direction according to the rule, and a parallel ray of light, another which is parallel to the first light, falls on concave mirror. We are knowing it always the normal phenomena of refraction takes place here in it, where these two rays, first ray and second ray, will intersect, the image will be formed A dash and B dash at focus. So whenever object is at infinity, the image is formed at focus. So what we will do in here, we will write here in the table that position of object, position of image, size of the image, nature of the image. So here in this case position of the image, it is for a concave mirror at infinity. Object image is formed at focus. Focus point here. See here, image is formed at a focus, very small in size as comparison to the object, because object is at infinity, so it is known as highly diminished, very small in size. And nature, see, it is inverted image is formed, and the image is a real, so it is called real and inverted image. So see the characteristic here in this case. Now second case, when object is beyond C, C stand for center of curvature, then see how the image will form. First of all, take a concave mirror with its principal axis, and on this principal axis this is position of pole, focal point, and center of curvature C. We are going to take an object AB beyond center of curvature, but not at infinity. We will take a ray of light parallel to the principal axis. We are knowing in the rule a ray parallel to the principal axis, after reflection it passes always through focal point. And second ray we are taking from the center of curvature. A line passes through the center of curvature and fall on mirror, spherical mirror, moves back in same path. These two rays are really meeting at this point, so final image will be formed here. A dash, B dash. This is real inverted between center of curvature and F, and small in size. So if one want to write its detail here in the second, so one may write it is the position of object is beyond F, position of image is between center of curvature C and focal point F. Small in size means this is called diminished. Real and inverted. In this case, see very carefully. Now we are going to look at the third case, when object is at center of curvature. See, if it is center of curvature, let us see the ray diagram carefully here. Concave mirror, principal axis consider, take this is point pole P, focal point F and center of curvature C. See, for the ray diagram, we will take an object AB at center of curvature, same like as the previous. First ray we will take parallel to the principal axis and second passing from the center of curvature. In this also. So see, this is a ray of light. Parallel to the principal axis, passes always through focus, and second ray passing through the focus after reflection. Here in this we will take passing through the focus because object is at center of curvature. So second ray we will take different from the previous because second ray is passing through the center of curvature, but here it is passes through the focus. When a ray passes through the focus after reflection, it becomes parallel to the principal axis. So second ray will return in this direction. These two ray, reflected ray meets really here, so its image, final image will be formed at C only, at center of curvature C, A dash, B dash. It is same in size and at same position, real and inverted. So if we see in the table, position of object at center of curvature C, image is obtained at center of curvature C, same size, that is neither diminished nor magnified, real and inverted. Now we are going to see the fourth case. In this fourth case, when an object is in between center of curvature C and focal point F. Then see here, take a position of concave mirror with principal axis. Consider the position P, pole, focal point and center of curvature C. We will take an object here A and B. In between C and F it is. See how the ray diagram will form and where will be the position of image. So to make it, see here, first ray we are going to take parallel ray applied parallel to the principal axis. The rule is always passes through the focal point. And second ray we will pass from the focus as we have done position of a mirror little c like it. So this ray of light will come up to here. Now a ray passing through the focal point becomes parallel to the principal axis. See, really these two lines meets beyond center of curvature. So final image is here formed beyond C of object AB. It is A dash, B dash, larger in size here and inverted and beyond C. So see the detailing characteristic of the image formed by it. Now position of the object, it is between center of curvature C and focal point F. Image is formed beyond center of curvature C, larger in size. This is called magnified. Real and inverted. So these are the four characteristics, and this is the position of object and it is position of image. Now see the next, when object is at focal point F. When object is at focal point F, see where the image will be formed by the concave mirror. Let this is concave mirror, their reflecting size is at here. Principal axis, pole, focal point, center of curvature, and we are going to take an object AB at point F. The ray diagram, consider one ray parallel to the principal axis, always passes through the focus. Second ray we are taking normal. Normal reflection. This is angle of incidence and angle of reflections. Reflection is equal I and R. But one strange is here. both refracted ray becomes parallel, and both is moving this side parallel. So parallel rays never meet, or we may say it is meet at infinity. So final image is formed at infinity. So in that condition, the image will be much larger size than the object. Then it is called highly magnified, and the real and inverted. So it is time to fill the table here. Object is at focal point. Up in the diagram, the image is formed at infinity. Very larger in size, very, so it is called highly magnified, real and inverted. This is. Now one more condition we are going to discuss, that is when the object is in between F, focal point F, and pole of the mirror, then see how the image is formed. So to show this, it is required to see much more carefully here. Take the points as we are taking. P, focal point and center of curvature C. And we are going to take an object AB between focal point F and pole P. So to make a ray diagram, we will take first, carefully see, parallel to the principal axis always passes through the focal point, the first ray. Second ray we will take from a center of curvature, fall on here and return back in same direction. When this to reflected ray moves this side, the distance between both is increasing, so can never meet on this side. If a person is viewed from here, previewed from here, see, he will feel that. Let us proceed this both reflected ray here in the forward direction by dotted line. It seems to come from a common point O. So see, the virtual image is formed here. A dash, B dash, here in it. So in the concave mirror, the virtual image and erect it is same like as B and B dash both is on upside. So it is called erect image, and virtual image is called why it is not real, why it is not made by the actual line meeting, actual rays meeting, but it is seems to come from point O. That is why it is called erect and virtual image. So let us try to feel this table. The object is in between focal point F and pole P. Images were formed. Beyond mirror, beyond mirror. Next side, larger in size means magnified, erect and virtual. So see here in case of concave mirror, very carefully here in this table, at every positions real and inverted image formed, but only one situation is when erect and virtual image is formed when object is in between F and P. So beyond mirror on next side it is formed. Now we are going to see formation of image by concave mirror. It is under 2 point only. First, when object is at infinity in a concave mirror. So let us see first of all position of a concave mirror. This is convex mirror. Because concave mirror we have already seen. Convex mirror, under case when object is at infinity, so this is the position of convex mirror with principal axis. In convex mirror, the focal point and center of curvature found in right side. This is the point of pole. Object we always take left side, either in mirror or in lens, any type of lens or any type of mirror. So object here in this case is at infinity. And we are going to take for the formation of image 2 ray. The both ray in this case we are going to take parallel to the principal axis. We are knowing convex mirror has property to scatter rays, so it is reflected in same side. Phenomena of reflection will take place and this distance between both is increases. So image cannot be formed on lens left hand side, but when if one is observing from this side, so when it's increases this both refracted ray, it seems to come from a focus. So this side, so surely erect and diminished image will be formed. Very small in size it will form, and it is beyond the mirror it will form. Now this is time to fill the table here for convex mirror. The position of object we have taken at infinity. Position of image behind mirror on second side. Size of image highly diminished, very small in size, erect and virtual. Why virtual? Because it is not, image is not making by actual meeting the line, but it is seems to appear from the point. That is why it is virtual image is here. Now the last point, the formation of image by convex mirror when object is in between infinity to pole at any point. So let us see this. Convex mirror with principal axis line. 2 points, focal point and center of curvature C, and pole P. Now see, we are going to take an object AB. So to complete the ray diagram, we will take first ray parallel to the principal axis. It will after reflection, it seems to come from a focusity rule. So take this is will be reflected in this side. Second ray seems to come from the focal point. It's fall here and reflected back in. When one will be observed from this side, it seems to come this ray from C and this ray from F. So these two rays virtual rays meeting at this point. So final image will be formed here, A dash and B dash, small in size, behind the mirror, virtual and erect image is formed. So now this is time to fill this observation table. Position of object between infinity and pole P. It is behind the mirror. Small in size means diminished, erect and virtual. So see, the image formed by convex mirror is under two circumstances only, and both is erect and virtual. But in case of concave mirror, always real and inverted is obtained, but only one case when object in between focal point and pole, erect and virtual image is formed. So this is for the topic. Thank you and have a nice day.